Hey everybody, so in this video we're going to continue talking about rational exponents, but this time we're going to focus on equations. Okay, so before we get started talking about equations, I just want to remind you of our definition of rational or fractional exponents. Okay, so remember we were saying that if you have a fractional exponent, the denominator of the exponent is the index of the root. Okay, and the numerator of the exponent is the power. Okay, so we can either write it like this, or we can write it like this. Okay, and as long as they all exist, then they're all equal to one another. Okay, all right, so let's go ahead and do some examples of equations. Okay, so let's talk about how to solve them. Okay, so these types of equations where you have a variable in the base and a number in the exponent are called power equations. Okay, so the first thing we're going to do is isolate the x to the p. Okay, so the variable to the numerical power. Okay, so we're going to do is isolate that. Okay, then we're going to change to radical form. Okay. Then we're going to take the appropriate root. Okay. Then use the corresponding power. Okay, now remember we talked about this when we were talking about root equations. Like when you have the cube root, what I mean by corresponding power is you would use the cube power, right? If you have a fourth root, you would use the fourth power. Okay, all right. And then the last one is to finish solving normally, whatever that means for that problem. Okay, so we're going to isolate, change to radical form, use the root to get rid of the power, use the power to get rid of the root, and then finish solving. Okay, so let's look at an example. Okay. Okay, so the first thing we're going to do is isolate the part with the variable to the exponent. Okay, so here we have the part that we're talking about. Okay, so what we need to do to isolate this is add 1 to both sides. Okay, add 1 to this side, that gets rid of the -1. Add 1 to this side, you get 16. Okay, now we're going to change to radical form. Okay, so remember the denominator becomes the index of the root. Okay, the base becomes the radicand, and the numerator becomes the power. Okay. All right. So now what we want to do is we want to get rid of the square. Okay. So that means we're going to take the square root, right? We're going to take the corresponding root. Okay. I know this looks a little bit funny, but that's all right. Okay. Square root of a square, that just leaves us with the radicand, which is cube root of x. Okay. And the square root of 16 is 4. Okay. Now we want to get rid of the cube root, so we're going to cube both sides. Okay. Cube root of x cubed is x. Okay. 4 times 4 times 4 is 64. Okay, so we're going to get plus or minus 64. Okay. All right. Now, one thing I wanted to point out is that it's best to take the root first and make the number smaller, okay, and then raise it to a power to make the number bigger. If we were to do the cube first, we would have 16 cubed. Remember, you don't have a calculator on the exam. So you're going to have to do 16 times 16 times 16 by hand, okay? And then you're going to have to try to guess the square root of that big number, okay? So it's better to take the root first and make it smaller, and then do the power, okay? Let's look at another example of this. Okay, so the first thing I want to do is isolate this x to the 3/4. Okay, so I'm going to subtract 1 from both sides. Okay, and then I'm going to divide both sides by -3. Okay, now I'm going to change to radical form. Okay, so remember the denominator becomes the index. Okay, and the numerator becomes the exponent. Okay, the base becomes the radicand here. Okay, now I want to get rid of the cube, so I'm going to use the cube root. So I'm going to take the cube root of this side. Okay. Cube root of the cube just leaves me with 4th root of x because these are opposites. Okay. The cube root of 8 is 2. Okay. Now if I want to get rid of the 4th root, I'm going to use the 4th power. Okay. 4th root of x to the 4th is x. 2 to the 4th is 16. Okay. One thing I wanted to point out about this example is that at the very beginning, for some reason, people are tempted to subtract these. Don't forget that this 3 is the coefficient for this term, okay? It's not like terms with the 1 because it's connected to this x. It's the coefficient, okay? This is a constant term. This is a term with a variable. You can't subtract them, okay? All right. Let's look at another example. Okay. So here we go. Again, the first thing that we want to do is isolate this term, okay? So I'm going to go ahead and divide this 2 on both sides. Okay, 1.4 divided by 2 is 0.7. Okay, and then I'm going to subtract 5.2 from both sides. Okay, so 0.7 minus 5.2 is negative 4.5. Okay, and then to get rid of this minus sign, I'm going to divide both sides by negative 1. Okay, all right. Now I'm going to change to the root form of this, okay? The denominator is my index, okay? And the numerator is my exponent, okay? The base becomes the radicand. Okay, now to get rid of the fifth power, I need to take the fifth root of both sides. Okay. Now the fifth root of the fifth power, those are opposites, so they undo one another, and I'm just left with cube root of x. Okay, over here, I'm not sure what the fifth root of 4.5 is. I can't think of anything that like times itself 5 times, give me 4.5. So I'm just going to leave it like this. Okay. Then I'm going to cube both sides to get rid of this cube root. Okay, so the cube root and cube are opposites. We're left with x. Okay, and here, again, I can't really simplify this by hand. Okay, so this is my exact answer. Okay, I just leave it in this radical form. And then if I want to put this into a calculator, I can always write it in exponential form, so 4.5 to the 3/5, and enter this into my calculator. Okay, so this is exact form with roots. Okay, this is exact with exponents. Okay, and if I wanted to get an approximate answer, okay, I would plug this into my calculator and I get approximately 2.47. Okay. Okay, remember the difference between exact and approximate is not how many decimal places out you copy. You could copy 1,000 decimal places here and it would still be an approximate answer because you have to round at some point. An exact answer is something where you haven't rounded at all, which in this case is only possible if you don't do the fifth root, okay, because this isn't an even fifth power. Okay. All right, so this is what you do if it doesn't come out evenly. You just leave the root like this, and then you leave the power like that. Okay. All right, let's look at one last example of this. Okay. So the difference with this one is that we have a negative exponent, okay? So we know what the negative exponent means. That means it goes into the denominator. Okay. So there's two ways to think about this. You can either think about multiplying both sides by x to the 2/5, or you can think about this as 9/1 and cross multiply, okay? Either way, you're going to get 9x to the 2/5 equals 1. Okay. And again, you're still trying to isolate this x to the 2/5. Okay, so I'm going to divide both sides by 9. Okay. Now that I have it isolated, I can change to radical form. So the denominator becomes my index. Okay, the numerator becomes the exponent, and the base becomes the radicand. Okay. Now I want to get rid of the square, so I'm going to square root both sides. Okay. The square root of the square, those cancel, so I'll end up with 5th root of x. Okay. And the square root of 1/9 is 1/3. Okay. Now I need to get rid of this 5th root, so I'm going to use the 5th power. Okay. 5th root of x to the 5th. Okay, that gives me x. Okay. And this is 1 to the 5th over 3 to the 5th, right? 1 to the 5th is 1. Okay. So this is going to be 1 over 243. Let me just double check that that is 243. I'm pretty sure. Yep. Okay. So this would be our final answer. Okay. This one is a little bit different because of the negative exponent. Okay, so the first thing you do is let that negative exponent move it into the denominator. Okay, and then you get rid of the fractions either by cross multiplying or by just multiplying both sides by x to the 2/5, okay, to get this. And then you're back in this situation like questions A, B, and C, where you're isolating the power part, changing to radical form, using the root, and then using the exponent. Okay. All right. I hope that makes sense, and I will see you guys